What is up, people? Hope this time the audio is better. Very close to the audio. What is up, everybody? So, I'll start in about a minute's time, but we'll just wait for a few more people to show up and we can get moving on because today's session is probably marking the end, I should say. Like, there are a few more topics that I want to cover. Probably I'll do that on Monday, but pretty much you're nearing the end of Dart, and if you guys know this much, you are very much good to go and start learning Flutter. So we're going to be looking into one of the important concepts called as generators in pretty much the Dart programming. Hi Sumit, thanks for joining the stream. So we're going to be looking at the generators today, and like I said in the end of yesterday's stream, we're going to be also writing code for the streams, right? Like stream, how do you handle streams and how do you build streams in Dart? That's what we're going to be finding out in today's session. So I'll just wait for another minute's time probably to make sure that everybody's joining and we can get moving on. Also, I'm going to be doing a recap of S3 as well because that's very important because we're going to be continuing from where we left off. And not just that, today's sessions specifically targets generators, which is like the core concept behind streams and how do you build streams. So I do believe that it's very important that you look into what we learned yesterday. So let's begin right now. Right. Everything looks cool. Yeah. So before we begin, I just want to do a quick understanding of what we saw yesterday. So yesterday's session was primarily targeted towards two important concepts. The first one was called as the futures, and the next one was called as streams. And we just looked into futures in depth. And also by the end of yesterday's stream, I also talked about what exactly is streams in Dart and why these two things are very important in order to have an asynchronous way of writing program. An asynchronous way of writing program is pretty much the standard when it comes to all the recent programming languages, especially when it comes to languages like Golang, Rust. You do find that these languages have inbuilt asynchronous support, and this asynchronous support handles your code in much better fashion. It improves the CPU usage, it reduces the unnecessary weightage on memory. It also provides much faster running applications. And yesterday I gave an example of a Tesla car running and how much of things that you need to do in asynchronous fashion in order to make sure that the car is running smoothly. And this is something that you will find a lot more, and all these recent programming languages are doing that by default. So a quick recap onto what futures are, like as the name suggests, these are basically things that might happen in the future, right? You're just telling it might happen in the future, and that's like the backbone of the futures. And when I say might happen in the future, I'm pretty much talking about things that are going to be happening not in a linear fashion. So this is linear fashion, and you're not happening or doing anything in linear fashion. Instead, you're doing everything in like an asynchronous fashion. Hi Pandey, how's it going? So yeah, so nothing is more anymore like one after another, rather it's all running parallelly, right? And this is what asynchronous support provides, and Dart is doing that by default. So in order to achieve this, the first concept we looked into was the futures, and futures are pretty much like a finite response values that might come in the future. So meaning when I say future, just think of it as a finite response, like a name that might come in the future, like a string response, like an integer response, like a double response or a boolean response. So these are the base data types, and these base data types are what you are expecting in the future. And this is also finite responses. When I say finite, it means that you do know what is the response you're going to get. You might get probably 10 items in the future, you might get 20 items in the future, you might get only one item in the future, and all of these are finite responses that you might get in the future, and that's what the futures are for. And also looked into the class called as future itself, and how we represent a future of type integer like this. And if you want to represent a future of type string, you say future of type string, and just open and close your angular brackets, and there you go. So these are the steps that you need to do, like basic steps, and that's actually the most important one that you need to look into as well. So in order to achieve the future responses, and this is how you do it. And the streams on the other hand are basically probably infinite responses. It might not always be infinite, but I'm using the word infinite because we never know what is that might come in the future. And this also could be continuous values. You will have a start point, you will have end point, and the start to end is basically not defined by you. Here you know that for sure there's going to be 10 responses coming, but in streams you never know how many responses you might get. You'll have a start, and by the end you will just be marked with an end. So this is it, just mark it as this is the end, and you just can stop the stream. And this is similar to how you are seeing the YouTube video as well. Like everything is running via a stream process. My camera is capturing my video, it is getting all the informations and encoding it and sending to the YouTube ingest server. And all of these are continuous stream of information which is then stitched as a video, and that's what you guys are viewing as a live video. And this is the entirety of or understanding behind streams, and this is what we also looked into yesterday. So the whole concept lies or pinches around the fact that everything is continuous. It's along in a pipe. And Sumit asked yesterday, like, is it something like unidirectional? So can it be one A to B is the stream that the value is flowing from? Can it also be reversed? It can still be reversed. You can still send messages from B to A, but not on the same pipeline. You need to create another pipeline, or in this example, integrate another object, and that's how you send information back. And this is something that you will find in today's session. You're going to be seeing how to create these pipelines, what exactly these pipelines are for, and how you can send information between A and B, and how these streams do work. So that's pretty much it, and that's what we looked into yesterday. We looked into all of it, code examples and stuff like that. So in about a minute or 2 minutes time, I'll start with the concept of generators in particular, and how generators are very, very useful, and we'll just move on from there. Let's sorry for that. It was a technical glitch, so I just quickly found it out and sorted it out. Anyway, so we're going to be continuing with the concept of generators, like I said. And what exactly are generators? So basically, like I said, you want to lazily load a sequence of information or data. When I say lazily load, you will not have a start point, you will not have an end point. And this is something that you'll find. I'll have few other informations also waiting for you, but just think of it this way, like a sequence of information that you want to send from a point A to point B, and the point B just receives it as such, as and when it wants to receive it. Could be like information like a list of data, right? A list of data has 0 to 10 numbers, and these 10 numbers is what you're going to send from point A to point B. But the point B just decides to receive it as and when it pleases. Probably it wants to receive the 0 to 10 information every 1 second. So first it receives a 0, and then wait for 1 second, and then after that it receives 1, wait for 1 more second, and similarly it wants to lazily load the data. And this is something, the new concept. This is actually was popularized by the Facebook, where you have the lazy load, where your entire post feature that you take. For example, you have in Facebook, you have this the feed that gets loaded, right? This feed that gets loaded is lazily loaded. You do not see every information being present right when the application loads, right? Or if you want to scroll up again, you scroll up again and things get loaded only after that. So this is the same concept behind lazy load, and this lazy load has been very famous. And this was actually done with a combination of few things on the client side and the server side, and this was complex. So as the programming language is trying to evolve, they want to bring this lazy load concepts as well inside it. And it's also popularized by Python for a lot of reasons, because you will see a lot of syntax similar to Python, and this is the whole idea behind lazy load. So hopefully you guys did understand about it. Now let's say you have a finite values 0 to 10 that you want to lazy load, meaning that the first page will show only 0, and only after you swipe up, which is basically what you're doing with the Facebook application loading, right? So let me write it here, yes, Facebook. So when you swipe up, that means that your feed gets reloaded, the next information comes into picture, which is an example 1. So 1 comes into picture after that, and you again do a swipe up, and that means that you want to load next information, so 2 comes into picture. So you do know that there's only 10 information present, and you're trying to lazy load every information of that sort. So this is the first idea behind generators, and this is also what you will find in this session. So we have 2 different types of generators, and like I said, there is no start and end to generator function, which is partially true and partially not true. I'll explain why in the next slide, but you can think about this way. So looping and waiting for information, right? You do have 10 information. It's not loaded in one shot, rather it's loaded in a sense that it waits for the next information one after another, and that's the whole idea behind generators. So there are 2 important types of generators, and the first one is called as iterable, and the next one is called as streams. That this is where streams come into picture. So this is the 2 different generators that are available, and I'll explain to you guys what exactly these are. Alright, the first one is the iterable class in Dart, and pretty much what you will find in normal usages, like if you create a list of information, you create a set of information, all of these are going to be representing an iterable class in the backend. So we'll just see what it looks like. Let's take for example a list of information, right? I have A, B, C, D, E, F, G. So this is the string information that I have, and these generators are basically called as iterables, what they're trying to do. So when you create it as a generator or the iterable in this example, you have a synchronous way of loading it. So when I say synchronous way of loading it, I do mean that it's basically for, so it's basically going to be one after another, right? A first gets loaded, then B comes into picture, then C comes into picture, D, E, F, and G. This is a synchronous way of loading information. So there's a person on the other side. So I'm here, right here, I'm the person A, and there's a person B, and I'm just going to be loading this information one after another only in a synchronous fashion. There is no jumping between A. At first I load A, and then I don't jump and load G. Rather, I just load the next one only. This is a synchronous load of information, and this synchronous load of information is possible through a class called as iterable. Now, iterables are pretty much what you see in basically, say you have a list of information, you can think of them as an iterable. So iterables could also be set, so they're the data structure, followed by hash maps or maps. So these are the 3 important data structures that implement iterable in the backend, and we'll see how it works out in the code wise itself. And you just can ask me if you guys have any questions till now. So this is like, think of it like a list of information that you're loading in a synchronous fashion one after another, and you're pretty much doing it in with basic Dart structures. Alright, so the first and most important one is that if you want to denote a synchronous function loading generators, if you want to denote a generator function, you will always use the star notation. So it could be a synchronous loading, which will mark with the example of a sync star, and similarly for an asynchronous loading, you will just mark it as an async star. And there are pretty much a lot of differences between these and these because of the way that data could be loaded. So we're just looking into sync star alone for now. So if you want to mark a function as a generator function, you will just mark with help of a sync star if you want to load it in a synchronous fashion. And sync star or the iterable is basically what we are trying to look into at this point of time. So just do some I'll just write some code, and you can see how it works out. and you guys can understand much more in depth as to how the code flow works when you are trying to create a first iterable generator. Because use the dart pad, and this is where we are usually going to get started, obviously, and we're always doing it. So first thing you need to know for this one is to have a main function obviously all the time, and we are going to have the next step as well. Hopefully the code is, you guys can see the code. Yeah, I do feel I can see that you guys, it's legible enough. In case it's not, just let me know. Excuse me, guys. All right, so the first thing that you need to know, obviously, always we do is just try to print statements, so we know how the sync flows. This is the start, and we'll just mark it like this, and we have the print. This is the end, right? Insert is there. Yeah, so this is the start, this is the end. Two informations are present. The next thing you're going to do is create our first generator function. Generators can live by themselves. You can just create a generator and leave them by itself, but it's pretty much important that you leave them inside a function, and I'll just show two examples for that as well. And there's nothing complex about this. It's a very simple thing to do. First thing we'll do is just create a list of information, right? So I want to create a list of data. I'll just call it as var information, right? And I'll just put it inside a list. The first information I'll say is A, the second information be B, C, and I am done. Yeah, so this is going to be my first ABC information. The next thing I'm going to do is try to load this information and see or what I can print. And you just need to understand at this point of time that you can still do or load this in a normal iterator, right? You can just load it like, put it inside a for loop and you can still load it. But this is first, we'll see that. So how do you do it in a normal way? You just say for where info in information, just use the for in looping statement, and you just print it like this right now. We'll just say print, and you just say this is the information that I have. I just use the $info, right? All right, so this is just saying this is the information that I have. What is it that is missing now? I don't know why it's getting an insert. How did it get an insert? Okay, looks okay for me. Okay, so this is just going to print it in a normal fashion. So we'll just run this as a normal loop. It'll just print it like a normal loop. Right, it just prints this is the information that I have, A, B, C, and N. So as everything is running in a synchronous fashion. But let's say that I want to introduce my next one, which is the iterable class. And how do I load it in an iterable class? So you have the same information that you have, same information list A, B, C, but instead of just putting it inside a normal list, I want to put it inside an iterable class. And you can still do that, and you just need to append the iterable before it only. So I'll show you how to do that. All right, so let's have the same information, and instead of just marking it as a variable, you can now mark it as this iterable of string. Nothing else changes, nowhere it is going to change. It's still going to work in a similar fashion, but if you mark it as an iterable, there are a bunch of different use cases that are available for it. So as soon as you mark the class or mark the data, the variable as an iterable, you have options to access a lot of different things. The first thing that you can do is just print the first item. So if you want to print a first item, what will you usually do? If you choose a normal list, you just information of 0, right? This is the index that you're going to give. But instead of doing that, you can just directly access the first element by just saying first. So this is the property that the iterable is going to give you. So if you are going to think of it in this way, the first information for this example is A, and after you have loaded the first information, the pointer now moves to B, and again you're going to, if you do first, the pointer will now be at B, so it will consider that as the first one. And this is going to be true for an finite number of data that is getting sent from point A to point B, and that's the whole use behind iterable. So it's going to lazily load this information. So the point A is sending first information A from let's instead of say point 1 is sending information to point 2. The point 1 is now sending the first letter A alone. So A is getting sent from point 1 to point 2. The point 2 is receiving it, and you just mark it as first. And when you say first, that's the first information is receiving, right? So you just print the letter A. Second information that is now going to send is letter B, sending from point 1 to point 2, and point 2 is receiving it. And still, if you see, it's a lazily loaded data, so it will not move the pointer, it will not move the counter, it will be still 0, it will still load it as first one. So we'll just see how it works out. For now, we are not going to be doing any more complex items from here. We'll just say print information. I want to print the last information that the information that I have, so just say last, and we are now done. Instead of just marking it via a counter, or in this example the position of the variable or position of the data in this list, we can just directly call them with first and last, and the iterable is smarter enough to understand where the first element starts and where the last element starts, because we know we are only sending a finite number of information. If it was an infinite number of information, these things won't work, and that's the thing that I told about async star. So just look into the next slide. But for now, this is the synchronous star, which is synchronous generator, and we can just directly do it in this fashion. This is something that is already inbuilt. It's already inbuilt as part of iterable. But what if you want to create your own iterable? Let's say you want to create your own generator function and generate information in a lazy fashion. And that's what I'm going to be showing you guys right now. So hopefully at this point it's pretty clear. I'll show you guys how to create a very simple synchronous generator function. Remove all this from here. We'll just go up and create our first method. I'll just call this method as sync iterable, sync func, right? Sync func is now going to send some information. I want to send, like, let me take an argument of probably, I just want to know number of items, and I'm just going to mark this function as sync star. So sync star. So as soon as you mark it with the sync star, it means that this function is going to return lazily loaded. It's going to lazily send information one after another. So first thing that you need to do is also set the return type. So I'm just going to set the return type as iterable of integer. So I'm just going to send only integer information, and it's going to be of type iterable. And if you say iterable, and if you want to send one information from point 1 to point 2, and you need to send it in a lazy fashion, the first important keyword that you will use is called as the yield. So you will say yield my position right now. So when I say yield, that means that I'm sending the first information out. Only if the receiver confirms, like if this is a point A and this is a point B, and only if the receiver confirms that your yield is received, the counter will move from first to second. And this is actually be true for everything. So the point B should receive every single information, and until the final data is being reached, it will continue to yield information, and you'll see how that is going to work out pretty much for us. So go back here, and we're going to now send some information. So I'm just going to send, for example, here I'll just say, for example, I want to start from variable counter is equal to 0, and I'll just say until the counter value is less than n, just to do I plus plus. I'm just creating 10 informations, and just creating 10 information, I'm trying to send it out. So instead of doing a return, right, instead of doing a return, you'll do something called as yield, and you'll say yield the variable, which is in this example the counter. Should be counter. So until, let's say you're passing the number as 10, so the counter will start from 0 and go to 9, and it will yield one value after another. So just say yield the counter, and this is pretty much what is the difference between a return and a yield. So a return will just return data and the function will get exited, but the yield will still hold the function until all the information is sent and received by the other party. It will still be the function will not complete. So this is like the simplest example of creating a generator by yourself. So this is actually a generator function. You can do a lot of things with this. This is an iterable synchronous iterable generator, meaning that you can use iterables to mark a generator, and this is also part of the synchronous process. So this is, you have successfully created this function, but how do you now uh, read the data from this? Now you have 0 to 10, right? And the 0 to 10 is basically sending information one after another. So you want to now read this information and print as the data is coming from the other side. This is also similar. You can just do a for in data here, because if there is a function that is sending data in a synchronous the yield fashion, you can still consider that as a normal data that you are receiving on the other side, and you can just print this data. So just see how it works out here. So I'll just say for variable data in sync func, I need to pass some information here, else I'll just pass 10 here. So I'm expecting 0 to 10 being returned, and I just want to now print this information. It'll work similar to that. So just say print dollar data, but I'm just going to say this is after receiving it. So you'll see how it works out. So this is after receiving it. So this is not like sending information at one go. It's sending one information from point A, the point B is receiving it, and we are trying to print it. So you'll see how it works out here. Before we are going to do a yield here, I'm just going to print one more statement here. I'm just going to say print, this is before sending the data. So this is before sending the data, right? The first counter will be 0. So the first print statement get printed, which is this is before sending the data will get printed. After that, 0 will be yielded. The yielded function, which is right here, will get the information and just print the first data alone. And it will go back again here. It will do the next one and yield it again. So just print this and run this. You will see for yourself how the yield function works. Awesome. So this is the example that I told. First, it is actually doing a simple print here, and the counter is moving to 0. The counter is sending the information, and we're yielding it. And as soon as you receive it, that means that the yield is going to get completed. Second step, it goes back to the counter, which is the top here, and this function is not getting exited until we print all the 9 information, so the 9 data that is coming from point A to point B. So this is how you create your first generator function, and the generator functions are very, 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 very useful. This is pretty much used almost in every asynchronous programming framework that you see, asynchronous programming languages that you see, and it's also going to be the most important one that you can find. Hopefully I did cover as much information as possible. So awesome. So Sumit got it right. So when A sends data to B, but when B only acknowledges that A is sent and received it, only then it will move to the next pointer. That's exactly what I was trying to cover. That's very good. That's the whole thing behind iterators. If you do a normal list, right, it will send everything at once. That's not what we want. We want to do it in one after another lazy load fashion. That's exactly right, Sumit. That's the correct understanding. That's what iterators are for. And just think of the same thing, and if you want to just do it in a synchronous fashion, that's pretty much how you create your streams. The streams are just not things that you wait and print in a synchronous fashion like this. This is still synchronous, right? Only after the 0 gets completed and 1 is received, it moves to 2. After that, it moves to 3. After that, it moves to 4, 5, 6, and 7. But if you don't want that, you want to write things in a asynchronous fashion, then you are going to be creating our streams. That's what you're going to be finding out in the next slide. Yeah, I'll just take a small break and I'll just come back and cover the concepts of streams for you guys. Right, so let's move on to this, the concept of generators now. Generators, I mean, sorry, streams now. Streams are similar to iterators again, iterable class again, but like I said, it's going to do everything in a asynchronous fashion. And just like you yielded in your iterator, just like you did it with the normal iterable class, that's how you're going to do in the same with the streams as well. But there's a couple of differences between how a stream and an iterable class works. The first important difference between a stream is yesterday's session we saw like we have a couple of listeners to it. There is no concept of catching it, there is no concept of receiving it. Rather, it's all about listening to these streams. And the first type of listener is called as single subscription listener, and the second type is called as broadcast listeners. And you need to be aware of the fact that the code wise it's going to be the same. It's going to be the same way that you're going to read these the code way is going to be the same way you generate these streams, but when you're receiving it you cannot do it in a normal for in loop. Rather, you need to attach a listener to it. You need to attach like a then operator. You need to attach some things to it. Only then you can be able to read this information. That is also the most important one. Right, so let's look into the concept of streams, like how do you create it and how you can read it as well. Yeah, I'll do it. All right, so I'll just quickly cover two things here. So the first operator that you're going to use is obviously yield again. The yield again is going to be acting as the generator. So we have a async star function now, and previously we had only the sync star, which is synchronous loading of data. But here we're going to be having the async star function that is going to be marking it or denoting it to be an it's going to be denoting it as the stream generator. The stream generator is created, and in place of just doing a for in loop, we're just going to be replacing that with something called as an await for loop. And this await is obviously used everywhere you see in the case of an async operators. Either it be futures or it be for streams, you will obviously use this await in all these places. So similarly, async and await is inseparable. You cannot separate an asynchronous function without having an await for. And this is going to be how you're going to read the streams of information, and every single time the stream of information is coming, you'll load it, and you'll load it in a normal fashion and then try to probably print it or do anything of that sort. So just see a code example right now, and then I'll probably cover the next important topic of called as stream controllers. And the stream controllers are also very important. So let's go here and we'll create our next function. I'll just call it as async function, and I will just see how this pretty much turns out to be. So just call it as async function, right? I'll just probably call it as um, async func, and I need to have some space to see this function itself. So open and close brackets, finish it, and you just need to mark it as the first one. Just call it async star. So as soon as you mark it as an async star, that means that it's going to be a stream. It's going to create a stream of data. So just do something like this again. We'll just get int number. So the number up to which the data is going to get loaded. And you need to obviously mark the return type again. In the up one, we mark it as iterable, meaning that it's going to be a synchronous generator. So in this one, you need to mark it as stream of int. As soon as you mark it as stream of int, you need to obviously have a return type as well. But in generators, we don't do simple return values. We will do a yield of it. So just write the same function that we did up above as well. We'll just say for counter variable counter is equal to 0. We'll just say counter is less than number. We'll just say counter plus plus. Open close and finish these brackets, and instead of returning, we will just yield the data, yield the counter. Awesome, right? Pretty much everything is done. So just also add a print statement here. Print this is before the yielding is done. All right, So we have the counter done, yield is done. The next thing that we need to do, obviously, at this point of time is to have a mechanism to receive it. And the receiving part is very simple, but you also need to understand that you cannot directly receive it. You need to use an await for. But if you use an await for, you need to also mark that function as async. So that's what you're going to do now. So just have a receiver function here. So just call it as receive streams, and it's just going to be receiving a stream of int, right? That's what we had here. We're just sending a stream of int, so it's just obviously going to receive a stream of it. I'll just mark it as stream, and obviously have an open close flower brackets, and I'm just going to be marking this in async only, because async is I'm just telling that future data is coming in, so just read it and don't do much about it, and it's going to return a type of future. So just converting a stream of information into a future information and then sending it probably outside. So now is the time to read this information. So what I'm going to do is just call in await for, I'll just say where data in stream. I'm just going to try to print this information right now. So just a print information from the stream is dollar data, right? That's done. And you need to obviously have a return type, right? You can just return without anything. So just say return as probably return the final information that you get, say data. So data will be a local variable, so it'll just throw an error. I'll just return some, like we can have like a sum value. We'll just call it a sum is equal to 0, and we'll just do something like this, sum plus equal to data. So it just return the sum information right here. What we're trying to do is add all the information, add all the data streams that are coming in. I'm just trying to do some kind of response here. So we have a sender generator here, and we have a receiver here, and just time to look into and put both of them into practice. So in order to do that, just remove these lines. You don't need these lines anymore. So this is what we're going to do. We'll just put the first line, which is going to be the stream. So we'll just say stream is equal to what we call it as async func, right? So async func, we just need to pass some data. So just pass 12. Great. Next thing we're going to do is we're going to be now sending the stream of information and probably waiting for some results. So just say where some information is equal to, because we have it as a future, we can't directly leave it, so we just need to say await, and we just need to receive the information, right? So we'll just say receive streams and pass this stream. So pass the stream variable. So pretty much this is what we are doing. We just now completed loading this information, and at the same time you have done completed waiting for this information. So it's just say receive streams is not there, spelling mistake, receive streams, yeah, looks like pretty much what I wanted to write. Okay, I just want to print this now. The sum information is equal to dollar sum. Done, right? Why is throwing an error? Does look like, yeah, what is happening? I don't know. Why is the compiler throwing this error? Because we already marked it as async. Alright, I'm just gonna look. Receive streams, the name of the function is also correct. Receive streams, future of an int, and we also returning some data. Everything looks pretty fine to me. Alright, we'll just see how it looks. Wait can only be used in async or methods that are synchronous. This is a synchronous, right? Alright, we'll say where sum is equal to receive Okay, we'll go here and we'll see. Run this application. Great. So this is what is happening from here. So what is happening is that it's not happening in a synchronous fashion, rather it's happening in asynchronous fashion. So this is this first line, and first line got printed from the main function. This is the status got printed. But if you see here, it is just skipping this because it should be in a wait. I don't know why it is happening. So we just remove the first three lines. So the start end is done, but in an asynchronous way of loading, it is loading the information as this is before the yielding is done 0 1 2 3 4 5 6 till 11. So this is pretty much what is happening, and that's what you guys are have looked into as well. Oh my god, it's got, oh my god. So this everything gone in a, this did is just did it by mistake. Anyway, we'll write it again, no problem. So I just hope that you guys did understand that part for now. So this is how an asynchronous loading works. Yes, that's true. The yield is just like a return type, return keyword, and it's just this how you're going to be, instead of using the normal function, you only use it for generators. And if you don't use it for generators, you don't use a return keyword in a generator. You only use a yield keyword in a generator, and that's pretty much the main difference between these two things. So that's what I wanted to really cover here. So hopefully I've just covered everything at this point of time. I just want to also give a brief introduction into something called as the stream controllers, and what the stream controllers are going to do for you. And if you're going to be creating a lot of asynchronous data loading, right, it's important that you cover the concept of stream controllers as well, because without stream controllers you will just be writing haphazard ways. You will be creating streams left and right, and all be happening in haphazard fashion, which we don't want. So that's what we're going to be covering in about 2 minutes time. Just take a quick break. Looks like I need to recover the dart pads. This one I just need to recover all the code, which I will do and come back to you guys in about a minute's time. Does it work? Okay. Okay, I'll do that. I'll come back to you guys. So just give me like a couple of minutes time. Thanks, Sumit. Thanks, Q. I just had it mute by mistake. Anyway, so this is the thing. So just going to quickly create another stream functions to so that you guys can see it. Have a stream int. I'll call it as a sync func. Right, we'll just have integer number, and we'll just mark it as async star, so that we know that it's going to be asynchronous, and we're just going to be now yielding some information. So for variable counter is equal to 0, counter less than number, counter plus plus, just yield this on out, yield the counter. Awesome. So you have that created, generator is created. It's going to be a stream generator. The next thing you're going to do is the receiver generator. So it should be a future of int. You can even just leave it as void. Nobody cares. Just leave it as void and just call it as stream receiver. So this is going to be the simple receiver that you're going to create, and it's going to be of type stream of int and stream, and it should be in a sync function. Make sure to have it as a sync function, and just say await for variable data in async func of 10. I'm just gonna now print this information. So I'll just say probably printing async star data dollar data, and there you go. We've created a stream creator generator and a stream receiver, and stitching together we just have to do something like this. We just have to do like first create a stream. So just say var stream is equal to async function, pass the number as 10, and the next thing is going to be just pass it to the reader. So I'll just say stream receiver, and we'll just pass the stream directly, not the value, just pass the stream directly. So this function is going to return a stream of information, and the receiver, only after it gets received is this going to, both of them going to come out. And we just saw also that it was not going to run in a synchronous fashion. First the lines will come, and only then the receivers will get started and start getting printed. And this is the whole idea behind sending a receiver, setting up a receiver and creating our own streams, right? But let's say that you have multiple streams created. You have one stream right here, and you have a bunch of different streams also present. And one of the most important mistakes that you should avoid at this point of time in trying to create streams is to not just create streams as and when you please. And since these streams are going to run in asynchronous fashion, this is something similar to what I told yesterday. When you have the power to do something in asynchronous fashion, you just do or make sure to do things in a much more careful sense. You want to make sure to always have a mechanism to debug things and not just leave it high and dry, right? You just want to don't do that. So to just avoid doing things like that, you just make sure to always have a mechanism to control your streams. And that's where the concept of stream controllers comes into the picture. So what the stream controllers are basically is just like a controller option to handle bunch of different streams. So there's a stream one that you have. This is going to send probably all the information about weather continuously. Let's say this is the first one, it's weather stream. The second one is going to be like a radio stream, just going to continuously send information from a specific radio frequency like 99.1, 99.2, something like that. It's going to be a radio stream. And you have another stream that is very similar to the weather stream. Let's say it's trying to send information as similar to precipitation information, right? Precipitation stream. And you as a developer has to be very careful as to what are the streams that are looking like it's very similar to each other, and you should reduce the number of streams that are present. And in order to do that, you create one main controller stream, and this controller stream is nothing but a simple variable that is going to control the streams. And in order to determine where this stream should be created, or for example you have 3 different listeners here, and in order to control where these streams that need to match these, you are going to be passing it via a controller. And this controller will just determine what are the streams that you need to check for. If you are looking for a weather stream, the controller will decide like, okay, the weather information is already present in one stream called as weather stream, so I'm just going to be putting all the information inside it, and I'm going to create a pipeline to receive and read it. And similarly, you want to now listen to radio, And the radio, as soon as you said that this radio is going to be there, you're just going to be creating a pipeline to the stream, and it's going to send it here. Let's say you want to hear cricket score. The cricket score is similar to a radio, right? So there is no stream that is available for creating reading cricket score. But what you can do is just pass it to the radio stream, and you can just send and create another pipeline back like this. And you'll try to reduce as many number of streams that you're creating and pass everything along a central controller that will make sure that you're not overdoing things, like not overdoing a lot of streams, not creating multiple different streams unnecessarily, even though you can just clump things together. And that's the whole idea behind using a controller. And this whole bunch of different things that you can do along with help of controllers. You can just add things, you can probably connect things, and there's a lot of different concepts that is very very advanced, if you ask me, at this point of time, to do with controllers and stream controllers in particular. Stream controllers are very important. There is nothing called as a future controller, because you can create futures, and because it's going to be a single finite information that's going to come along. So you just have to make sure to have always a good controller in place for a stream. So that's pretty much it. So we've covered all the topics that you wanted to cover, and in tomorrow's or the Monday session, probably I'm not going to be doing a stream tomorrow. In Monday's session, I'll cover a few more additional things that are possible with Dart, like runes, isolates, and few other things that are very cool to look into that is not available with other programming languages. So just cover what the differences between that, and we'll just see how this is going to take us to the next step for Flutter. We might have a Flutter class coming up around the corner, I don't know, but we will see how it turns out to be. So I'm going to be finishing my stream right now. If you guys have any questions, just drop them right now, or else awesome, that's the best way to put. So Sumit says that controller is just like a valve. Exactly, you're just going to control that flow of information, and you decide which valve it is going to be. So you have like probably three different streams, three pipelines going like this. And as the developer, you should be aware of creating this stoppage here to determine that if person is asking for a valve A, you open only valve A, you don't open all these valves. You just open only the valve A, create a stream and create a connection, and set it along with the receiver, and that's the whole thing that you're going to do. So excellent way of putting, Sumit. So that's pretty much what you think of. You can think of controller as a valve for a pipeline. So that's pretty much it. Amazing. Alright, so that's pretty much it from me, guys. I'm gonna just drop the stream right now. Hopefully you did, guys. Hopefully you did learn something new today, and pretty much the same things from here. So just check me out on my YouTube channel. It's called as Coder Monk, and you can just check me out right there. Go to Coder Monk, and you'll be finding me right there. And you guys can subscribe to my channel, and you can also connect with me on Coder Monk underscore for my Instagram ID, and you can just ask your questions there. I'm always like responding to things right over there, and I'll pretty much see you guys in the next session. Thanks again, Sumit. Thanks again, everybody, for joining the stream. It's been pretty fun, and also going to be like I said, trying to do another one stream on Dart pretty much on Monday. I'm not very sure about that, so I'll just see if you can do one session on that day. And if you cannot do that, that's pretty much it. The end of Dart sessions. See you guys in the next one. Thanks again for joining. Until then, Bharat. Peace out. Have a super awesome day.